Hello and welcome back to Astronomy 104, the Astronomy of Planets. In this module we're going to be wrapping up our study of the foundations of astronomy. So the class began with a look at the night sky and the development of science and the scientific method, and we really focused for the first few modules on the history of mapping planetary motion, mapping actually both the motion of stars across the sky as the sky rotates around the Earth, and then mapping how the planets move with respect to that. So this was a long process. It required detailed measurements of the positions of planets and their motion and stars, and very precise measurements of these positions. It also required some key insights that people made and careful mathematical analysis of the data that was collected. And in addition to all of that, it also required different types of evidence to be discovered that would confirm the theory. In this module, we're going to complete the picture of how light interacts with matter. The historical route that got us there it began with the invention of the spectrograph 200 years ago. If you'll recall from last time, the spectrograph is an instrument that takes light and spreads it out over its various wavelengths, its spectrum, so that its intensity at different wavelengths can be measured. In this module, we're going to go back to the invention of the spectrograph and discuss the different types of spectra that were first observed, because that's sort of where it all began. We'll see how sorting out how to explain those observations eventually led to quantum physics. We'll then see how this understanding of the quantum structure of atoms and the way they interact with light enables us to go beyond simply plotting a planet's changing position across the sky and the changing positions of stars and all of that. We can now, using this, we can determine an object's chemical composition, we can determine its temperature in many cases, its intrinsic brightness, and therefore if we can determine how much light it actually gives off, we can also, by looking at it in the sky, we can see how bright it appears at Earth, and that allows us to determine its distance. We can determine its velocity relative to us, so a radial velocity. And then with that, if the object can actually be resolved, then we can determine how quickly it's rotating. So there are a lot of things that we can determine by knowing how light interacts with matter. And so this module really completes the picture that we began exploring in the last module of how modern astronomy is done. Last time you learned about technological advances in the last 400 years since the invention of the telescope that have allowed us to capture increasingly faint and better resolved signals from space. In this module, we're really going to deal more with the physics. It's only in the last 200 years that we've come to understand light and its interaction with matter. We're now able to sort out the physical properties of an object at the atomic level just by looking at it. What you're really going to be seeing here then is how astronomers are able to integrate that knowledge of how things happen on the smallest scales that exist and incorporate that into the study of things that are so far away that we can only look at them. Enjoy.